A warm good morning to all. I am Karthik, Assistant Professor, Mechanical Engineering Department, SMS College of Technology. Here in this video lecture, we have seen about human rule, copper nickel phase diagram, allotropy of iron, ferrite, and oscillator. So in this video, we are going to see about the cementite. So cementite, which is also known as iron carbide. As I like to say here, this iron carbon phase diagram has a name known as has a name, other name known as iron carbide. So or otherwise known as iron cementite phase diagram. So as this name implies that cementite plays a major role in this formation of iron carbon phase diagram. So the cementite, also known as iron carbide, is also known as Fe3C. Fe3C is a compound of iron and carbon. It is hard and brittle material which forms a distinct phase in certain steel and cast iron. So the cementite has a specific crystal structure and plays a significant role in determining the mechanical properties of these materials. This cementite has some key features. The first one is chemical composition. Cementite has a chemical formula of Fe3C, which indicates it consists of 3 iron atoms for every carbon atom. So its composition is fixed with approximately 6.67% of carbon by weight. So this crystal structure, cementite has an orthorhombic crystal structure. In this structure, these iron atoms are arranged in planes, forming a lattice with the carbon atom occupying the interstitial sites between iron atoms. So taking the other properties like hardness, cementite is extremely hard and brittle compared to the surrounding phases in this steel and cast iron range. So its presence can significantly increase the hardness and strength of material. So if we want to increase the strength of a material, we should have a cementite microstructure in the composition, so that hardness and strength can be improved. So compared to the when it takes microstructure into the consideration, cementite often forms a constituent phase in certain steel microstructures such as perlite. In pelletic steel, alternative layer of cementite and ferrite which is combined forms perlite during the ejector reaction, resulting in lamellar structures. Taking wear resistance, due to this hardness, cementite contributes to the wear resistance of steel and cast iron. However, excessive cementite content can also lead to brittleness during the material toughness. So here there are two terms. First is brittleness, another one is toughness. Brittleness, here the material, if it is brittle, if you apply a load, it can't expand, it will break. Or this brittle failures has a catastrophic property. In other words, we can say they don't show any indications while the materials fail. A brittle material will fail suddenly. Okay. The next one is material toughness. The material toughness is the ability of the material to withstand sudden impact load. For example, if we take a rivet, okay, the rivet should have a toughness property so that it can withstand the sudden pressure which is applied on it with the help of a hammer. So the next one is precipitation. Cementite can also precipitate from arsenate during cooling process in certain steel alloys, particularly those with a high carbon content, forming a network of cementite particles known as primary cementite. Cementite is an essential constituent phase in steel and cast iron, influencing their mechanical properties such as hardness, strength, and wear resistance. Understanding the formation and distribution of cementite in these materials is crucial for optimizing their performance in various applications, including tool steel, structural steels, and wear resistant components. The tool steel and structural steels, as I already said, they have These two types of seals should have highest toughness, so that it can helps in the formation of helps in